Today my topic is conservative force and non-conservative force. This is very important topic. This is helpful for different purpose. So first we have to know what is conservative force. Before the definition, we take an example. That is, let us consider a different path. That is, this is path 1, this is path 2, and this is path 3, and this is a particle of mass m. And let us consider in this path, that is BCA, the work done along BCA, we can write mgh. Work done along BCA, we can write that is mga. So work done along BCA, we can write that is mgh, and work done along this path, that is path 1 or path 2 or path 3, that is minus mgh. So the work done in the entire path, so in the round trip, the work done by the force, that is 0. This is the central force. So we come to the very important conclusion: work done by the force is 0 in the entire trip. So a force is said to be conservative if work done by the force on the particle that moves in a closed path is 0. So this is the conservative force. So there are so many conservative force. First, that is force of gravity. This is concept, that is force of gravity. Force of gravity is conservative force. Elastic force, nuclear force, magnetic force, electrostatic force, gravitational force are the conservative forces. So, and in this case, we have to remember one important thing. In conservative force, the work done depends on the position of points, only depends on the position of points, but not along the path. Actually, in case of conservative force, this work done only depends upon the position of the points. Points position depends करे. So, but not the path. This is very important conclusion of the conservative force. And we also know the conservative force, that is F is, that is conservative force. So F equal to minus dV dr. So actually conservative force can be expressed as a negative gradient of scalar quantity. That is V is known as that is potential of the field. So conservative force is expressed as the negative gradient of scalar quantity. This scalar quantity is the potential of the field. When such force, this conservative force is also central force. Next we come, that is central force. What is central force? Actually, this is the formula of central force. Actually, central force is a function of distance. So a force is said to be central force if it is function of distance between them and always acts along the line joining them. So this is the central force. Central force actually a conservative force. So gravitational force is also central force. And next we come to the another important definition, that is non-conservative force. Non-conservative force, actually there are fully difference between the conservative, totally opposite. So work done is not 0 in the entire trip. So force is said to be non-conservative force if work done by the force on the particle that moves in a closed path is not 0. So here in case the work done in the entire path is not zero. So all frictions or dissipative force are the non-conservative force. Actually, here in this concept, the force is said to be non-conservative if work done by the force on the particle that moves between the points depends upon the path. So this force only depends upon the path. So this is the non-conservative force. So from this concept, we can easily define what is conservative force, what is non-conservative force, and definition of central force with examples. This class is very much helpful for all students. I think all students watch my entire video and like, share and subscribe. I am very happy that all students are benefited to my lectures. Thank you, all my dear students.